Hello class. Today we are going to talk about polygons. That's right, we're not talking specifically about triangles. We're still going to use those, but we're moving on and starting to talk about polygons. And first thing we're going to talk about polygons is the angles of the polygons. All right? So, first thing here, theorem 7.1, polygon interior angles theorem. What this says is the sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180 degrees. Right? What's an n-gon? An n-gon is a polygon with n number of sides. Right? So a 7-gon has 7 sides. A 43-gon has 43 sides. So what this is saying is you take the number of sides, so in this case we have 6. So 6 sides minus 2 times 180, and that will give you what all of these angles add up to. All right, so we take the measure of angle 1 plus the measure of angle 2 plus measure of 3, 4, 5, 6, add them all up. That's going to equal 6 minus 2 times 180 degrees. Why does it do that? What's up with that? Well, here's the thing. All polygons are made up of triangles. All right, so here I have a triangle. It has 3 sides. It's got 1 triangle. What's the measure of the angle of a triangle? Well, we know from the triangle sum theorem that this adds up to 180 degrees. We have 1 triangle, right? Well, what about a quadrilateral? It's got 4 sides. Well, if we look at this, that's 2 triangles. So we have 2 times 180 degrees. Okay, well, what about over here? Well, we have 5, so that's, we do that. And then we could do one coming around here. And we have 3 triangles times 180 degrees, right? 6 sides is 1, 2, 3, 4 triangles, right? 4 triangles times 180 degrees. And if you'll notice, each case, the number of triangles is the number of sides minus 2. So this 9-sided figure, I have a little nonagon here, 9, it's going to have 9 minus 2 is 7 triangles, right? So that'd be 1 there, and that's 2, and let's see here, that's 3, splitting this side up, that'll give me 4, 5 there, and that's not a triangle yet, so there goes 6, 7 triangles. So we have 7 triangles times 180 degrees is going to give us our answer. All right? So that is where this theorem comes from. All right? How many triangles times 180? Because each triangle is 180 degrees. All right? Now, the corollary to the polygon interior angles theorem is that the sum of the measures of the interior angles of a quadrilateral is 360 degrees, right? Because that was 2 triangles, so 2 times 180 is 360. And we'll go ahead and write that down. Because what that is, that would be 4 minus 2 times 180, which equals 360 degrees. All they did is quadrilateral, plug in 4 for n. That's it. All right. Now, so that's really pretty easy, and it is useful in certain circumstances to know how many angles we have, how many degrees this whole thing adds up to. All right. Next, we are going to talk a little bit about some definitions. We have equilateral, equiangular, and regular polygons. Equilateral is just like an equilateral triangle. All the sides are the same length. So all 6 sides here are congruent. Next, we have equiangular. All right. Means all the angles are congruent. All the interior angles, that's important. All the interior angles of the polygon are congruent. So here, I have an equiangular hexagon. Notice the equiangular hexagon is not also equilateral like it was with a triangle. You can have equiangular, you can have equilateral, and they give you 2 different things, okay? And then we have a regular polygon. In a regular polygon, this is always convex, and it will be both equilateral and equiangular. So this is a regular polygon. And most of the polygons, when you were first learning shapes and things, were regular polygons, okay? So that is interior angles. That's some definitions. Now, what we are going to look at, we're going to take a look at exterior angles. All right. So here I have a nonagon, and we have all the exterior angles here. And the question is, what do these add up to? And so what we're going to do, we're going to take this, and let's just move these all closer together so we can see it a little bit better. And so as we move these angles closer together, look at that. That's a circle, isn't it? And so we see that's 360 degrees. Is that always the case? Well, let's change our nonagon around. Let's move it over here. Actually, that won't work. They do all have to be concave. Convex. Concave messes it up. All right, but convex works. So I can move these angles around. And they still come to a circle. Notice they don't overlap any. All right? Well, that's good for nonagons. What about other things? Let's try 6. I have a hexagon here. Let's move these around just to make it a little bit clear. See, hexagon, 6 sides. And look at that. It fits nice and perfect. It's 360. Okay, well, what about 5 of pentagon? 360. What if I make it concave, just to look at this? If I make it concave, notice we're going to have some overlap right here, right? And so that doesn't work. We've got some overlap. That's more than 360. So this isn't going to work for concave figures, but for convex polygons, we see it really doesn't matter. Let's see, that one all womply jarred because I moved some of the stuff. So we got some overlap here. Let's move that down there. Let's get us back convex again. There it is. It's just slightly convex, but it is. But we see still no overlap, 360 degrees. Okay. As long as it is a convex polygon, the exterior angles will add up to 360 degrees. And that is the next theorem. Polygon exterior angle theorem. The exterior angles of any convex polygon will add up to 360 degrees. So angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 is 360 degrees. Okay, and this is using one convex angle at each vertex. Okay, so we're not going to extend this out and have angle 2 and then another one over here. That would be no good. One angle at each vertex, and they add up to 360 degrees. All right, so let's take a look at this. Let's do some examples. That's all of the theorems and the technical information stuff. Let's do some work with this. How are we going to use these theorems that we've talked about? All right, so on these first ones, we want to find the sum of the measures of the interior angles of the indicated convex polygon. All right, and so these numbers are going to be big enough. I'm actually going to use my calculator today. Don't normally, but we will today. So let's see here. An octagon. How many sides does an octagon have? Let's see. That would be 8 sides. So what we're going to do, we'll take our formula, and this is looking for the sum of the interior angles. So interior angles theorem, the sum is going to be n minus 2 times 180 degrees. So in this case, n equals 8 because it's an octagon. All right, so we have 8 minus 2 times 180 degrees. So we take the calculator here, and we're going to skip a little bit because 8 minus 2 is 6 times 180. 1080. So our answer is 1080 degrees. Let me just type this in. We have a 15 gon, so what's n? Well, that's pretty obvious. It's 15, right? So n equals 15. So we have 15 minus 2 times 180. So 15 minus 2 times 180 gives us 2,340 degrees. 2,340 degrees. That's pretty easy, right? So real quick, pause the video and do number 3. All right, let's see how you did. N is going to be 24. So we have 24 minus 2 times 180. So 24 minus 2 times, times, did it again, times 180 gives us 3,960 degrees. 3,960 degrees. There it is. So that was easy. Let's take a look at number 4 through 6. This time the sum of the measures of the interior angles of a polygon is given. It is convex, so that's good. Classify the polygon by the number of sides. So, in order to classify by the number of sides, that means we have to name this thing. Is it a quadrilateral? Is it a pentagon? Is it a hexagon? That's what it's asking for here. So that means we have to know how many sides it has. Well, we're going to take our same formula. N minus 2 times 180 equals the sum of our angles. So 900 degrees. Now, I know a lot of you are saying, let's take that 180 and let's distribute that in. But that's the long way. It gives us big numbers. We don't need them. What we're going to do is divide by 180. So divide by 180. And let's see here, 900 divided by 180 is 5. So this is going to cancel out here. And we have n minus 2 equals 5. So now we add 2 to both sides, plus 2, cancels that out. And n equals 7. So this is a 7-sided figure. We need to classify it by the number of sides. We could call this a 7gon, right? But anything less than 10 you want to call by name. And so if you remember, and I know this is one that most people don't, this is a heptagon. Heptagon. And there's our answer. Depending on how picky your professor is, they might accept a 7gon. But heptagon is better. Anything less than 10 or lower, you want to call by name. All right? So that's it. You got this nice little formula. You plug, set it equal to whatever your angle is, your sum, and solve for n. That's it. So pause the video real quick and do 5 and 6 on your own. Then come back and check your work. All right. Let's see how you did. So we have n minus 2 times 180 equals 1620. First thing we need to do is divide by 180. Divide by 180. And let's see here. 1620 divided by 180. 180 is 9. Alright, so n minus 2 equals 9. We add 2 to both sides, and n equals 11. 11. So, this is more than 10. So if you want to call it by the number, that's fine. You could call this an 11gon. Notice this is not an 11-agon. It's 11-gon. Or, if you want to impress your teacher, this is a hendecagon. Most people don't know that, and so if you put that on a paper, whatever your teacher is will probably be impressed that you know what that is. All right, so let's do this. We have 180 times n minus 2 equals 2880. Going to divide by 180, divide by 180. And we get n minus 2 equals, we're going to this, 2880 divided by 180. 16. All right, so this is going to be pretty big. 16, add 2 to both sides, and n equals 18. So, yeah, 18gon. That is perfectly fine for this. I didn't put boxes around there. 18gon. Or, if you really want to be impressive, this is an octadecagon. Yeah, octadecagon. Or just 18gon will be fine. All right. Because it's more than 10. More than 10, that's fine. Just call it by the number -gon. Not 18-agon, 18gon. Okay, so that's that. Those are easy enough. Let's take a look at these next ones. For 7 through 10, we need to find the value of x. So we have x degrees. How are we going to figure out what x is? Well, we're basically going to do the same thing we did if we had a triangle. Right? If you have 3 angles of a triangle, or 2 angles, and you need to find that third one, you add them up and subtract it from 180, which is the total. Well, here we're going to do the same thing. This is a quadrilateral, so hey, we had a corollary to that. That said quadrilateral is going to equal 360 degrees. So we can just add these 3 up and subtract it from 360, and that'll give us x. So we have 95 plus 65 plus 45. So 5 and 5 and 5 is 15. That's 10 and another 10, so that makes 20. We have 205 degrees showing. We've got to find out what x is. So this is a quadrilateral, and we have a corollary that says they're going to add up to 360. So 360 minus 205. 1, and so we have 5, 5, 1, and so x equals 155. Not going to be 155 degrees because it's x degrees, and that would make it 155 degrees, which is no good. So since we already got the degrees there, we're just looking for x. 155. That's easy enough. Right? All right, so let's take a look at this next one. Move my camera down so we can see what we're doing. This one is not a quadrilateral anymore. Here we have 1, 2, 3, 4, 5, 6 sides. So how many, what will this total up to? I don't remember either. So we got a formula. N minus 2 times 180 equals our sum. N in this case is 6. So 180 times 6 minus 2 equals, let's see, 180 times 6 minus 2, 720. 720. And we're going to do the same thing. We're missing 1. We're going to add the other ones up and subtract it from 720. So 140, 130, 120. What's that one? There's no number. Yeah, that's 90. It's the right angle. And 150. Okay, so that's 0. Let's see, 2, 3, and 5 is 10, and 13 would be 23. So 2, 3, 4, 5, 6. 630, so 720 minus 630 is 90. So 90 equals x. And there's our answer there. All right. So again, not real bad. Pretty easy stuff. Let's take a look at, actually, you know what? How about you take number 9 on your own? There it is. And pause the video, solve it, come back, see how you did. All right, let's take a look at it. Number 9 is a little bit more difficult. We got 2 x's, right? Still not a big deal. This means we have equals 2x instead of 1x. But first, how many do we have? 1, 2, 3, 4, 5. So that's going to be 180 times 5 minus 2. So let's see here. 180 times 5 minus 2 is 540. 540. And now let's add up the ones we have. 90, 170. So that's 0, 9, and 7 is 16. So that's going to be 260. 260. And that'll be 14 minus 6 is 8. And that's 2. Now this is going to equal 2x because we have 2 angles that are x degrees. So we just divide by 2, and x equals 140. Easy peasy. Number 10. Number 10 is a bit different. Notice here the angles are on the outside, not on the inside. What are we going to do here? Well, let's see. Do we have information about exterior? We do. Exterior angles always add up to 360 degrees. That's it. 360. Now, this one I have a 4x and an x, so I'm going to write this out as an equation. So 98 plus x plus 162 plus 4x equals 360 degrees. Combine like terms, right? 98 and 162, 2 and 8 is 0, carry the 1, 9 and 1, and 6 is 16, carry the 1, so that's going to make it 260. Plus 1 and 4, so 5x equals 360. Because the exterior angles always is 360. So move the 260 over, so minus 260 minus 260. 5x equals 100. Divide by 5. Divide by 5. And x equals 20. And there it is. So, pretty easy stuff here. Important things. We got our formulas. Exterior angles. All right. Interior angles. The sum of the interior angles is always going to be n minus 2 times 180, where n is the number of sides of the triangle. All right. And on this, as we saw here, that's because it's made up of triangles, and it doesn't matter if this is concave or convex. It'll work either way. It's all good. All right. Exterior angles, however, has to be convex. If it is a concave polygon, it will not work. And we saw that on there too. But convex polygon, exterior angles is always going to add up to 360 degrees every single time. All right. So, hope you found this useful, and I will see you next time.